Hi guys, this is Joy. Uh, from today onwards, we will study the digital electronics using multisim, or you can say how digital circuits can be made through multisim and can be simulated. So, in the first lecture today, I am giving a small and brief introduction about the basic gates and circuits, required circuits that can be made through multisim, and how exactly the gates do work. We can get a clear-cut view for some practical perspective from some practical perspectives. Now this is a file that have been made by me, which is or which shows the basic gates like NOT, and OR gates. As you can see here, in the leftmost portion you can see the NOT gate connected through switch S0. In the middle you can see AND gate connected through switches S1 and S2. In the rightmost you can see OR gate connected through S3 and S4, whereas the outputs of not and OR gates are connected through blue, green and red LEDs or probes respectively. The switch that I have used here is a simple SPDT switch, that is single pole double throw switch. Single pole means simple 5-volt supply will be thrown to the inputs, and double throw, that means one way we can connect to simple uh, source to another load, and from other we can connect through some other loads. Here I have rotated the switches and uh, connected the ground here, and connected the VCC through here. If I press the run button and I press the switch key A, that means it goes off. Here I have given the dialog box S0 for NOT gate, and the key is A. That means if you press key A on the keyboard, you can operate this switch. Again you can push A, and here you can see 0. That means you are connecting to ground. That means you are giving 0 to the input, and you are getting high, and wherever you are pushing it to on, that is connected to VCC, you are getting a low signal. Similarly for S1 and S2, that is for AND gates rather, we have used input gate for AND gate and keys B and C respectively. So B for S1 and S2 corresponding to C. If I press B, then S1 is going on and off. If I press C, S2 is going on and off. Now for AND gate, we know the very important characteristics, that is for a high output signal, both the inputs should be high. That means here S1 is connected to VCC and S2 is connected to VCC, so we are getting a high signal, and consequently if we push any of the switch to low, the output goes low. That's for the AND gates. Now for OR gates, similarly S3 corresponding to key D and S4 for E. For OR gate we know that if any of the inputs are high, then output goes high. That means if we press D, S3 goes low, but S4 is still high, so output is high. Similarly if we press E, S4 goes low, but S3 is still high, so the output high. Whenever the two inputs are both high, then only the output goes low. Two inputs goes low, then only the output goes low. So this is the basics for you know uh, the NOT gates, AND gates and OR gates. Now you can also use SPST switch, that is single pole single throw switch, with this kind of a configuration. Here what I have done, I have taken simple SPST switch and connected this switch to the input signal, and the input of this gate is also grounded through register 1K, so that I can get ground connection and VCC connection through only one switch, only one SPST switch, instead of using an SPDT switch. And output is similarly connected to one probe or LED. Now if I press the run button, and then here you can see key space is throwing the switch, and throwing the switch off, the connection goes high. And if thus pressing the switch again, then it goes low, that is high input, low output, and low input, high output. And now another thing I need to tell you that for gate, how you can access the database, you can go straight here, TTL, write the number, or you can search from here. Here we have a list for low power and high power series, LS, HS, etc, etc. And you can straight go for 7404, that is the name here, hex inverter. Means in a single IC chip you have got 6 gates, A, B, C and D, E and F. You can choose any one and then you can do it. If you need another one, then you can choose this one and do the connections as required. If you want an AND gate, that is quad in 2 input NANDs, and you can do it so on. Like here I am selecting quad 2 inputs, so A, B, C and D, 4 only, that is quad, and 2 input NAND gates, that means we have got 2 inputs. And accordingly, for fulfilling the requirement, we can make these circuits by pressing the switches, placing the probes, placing the grounds and VCC connections properly, and we can run the circuit and simulate it. Now one thing remaining is that what should be done with these ICs. Like if you make some wrong connections, then you can't access these outputs. These probes you can find here, indicators, there it is, probe. You can have several probes, blue, green, orange, etc, etc. Also there is some switches, SPST or SPDT switch you can find here in the basic. Pressing the switch, you can have a large list of switches. From here you can see SPST and SPDT. You can also search from here and write SPST or SPDT and find those. Grounds and VCC connections are found from sources, like here you can see ground and VCC connections. So that's all for today. See you next time.